we discussed what it means to take the absolute value of something, and we also discussed what it means to have a variable inside the absolute value. And we associated both of those things with distance. And when we talked about absolute value equations, we said that whatever the absolute value was, in this case, in this example, we have 2x plus 1. But we talked about this being a certain distance from 0. With equations, that distance was equal to a certain amount. But now, with inequalities, it's either going to be more than a certain amount or less than a certain amount. So what I'm going to do first is explain how you should think about this inequality in terms of distance from 0, which we know is associated with absolute value. So this says that 2x plus 1, which I'm going to fill in these blanks down here, 2x plus 1 is blank spaces from 0. Well, it's not equal to 7 spaces from 0. Since we have a greater than or equal to, it's more than or equal to 7 spaces from 0. So, although what I'm about to do isn't going to be the graph as our solution, it's going to help us visualize what it means to be more than 7 spaces from 0. So if we have 0 right here on the number line, and we count over 7 spaces, we could either be at positive 7 or negative 7. Those are the two different places that we could be at if we are 7 spaces from 0. And we see that if we want to be equal to 7 spaces or more, well, we could be here at 7, or maybe we could be at 8, we could be at 9, we could be at 10, we could be at all these different points and it would be okay. Same thing down here with negative 7. We could be at negative 7, but as long as we are more than 7 spaces away from 0, then we're fine. So negative 8, negative 10, negative 1,000, all of those numbers are shaded because they are more than 7 spaces from 0. You can think of this almost like a force field. You tell people you have to stay 7 miles away from me or 7 feet away from me. They can't walk in a radius of 7 feet from you. So if you just think about this, we know that we're going to have two different parts here. Just like equations broke down, the absolute value equations broke down into two equations. The absolute value inequalities are going to break down into two inequalities. Well, what are our inequalities? Well, let's just look up here to help us. We can see that since we're shaded on the ends, we're going to actually have an OR statement. Because typically when we see shaded on the ends like that, we have an OR statement. So let's just look at this right-hand part first. That just says that 2x plus 1 has to be over, larger than 7. So what we can do is actually just take our inequality and rewrite it without the absolute value bars. So you're just taking exactly what you have up here and rewriting it without absolute value bars. And the other one, you take what's inside the absolute value, you flip the sign because now we're not talking about positive 7, we're talking about negative 7. And we don't want these values to be more than negative 7. We want them to be less than negative 7, less than or equal to. So you can see that one of the inequalities is exactly what you're given, but without the absolute value bars. And the other inequality is almost what you're given. You're given 2x plus 1, but we take the opposite of the number, so 7, we take negative 7, and we reverse the sign. And this is going to be the case for any absolute value inequality. And like we said, this is an OR statement, because we don't care if you're over here or if you're over here, as long as you're one or the other. So if we solve these real quick, we subtract a 1 from both sides. 2x is greater than or equal to 6. Divide by 2. X is going to be greater than or equal to 3. Or, if we subtract 1 over here and divide by 2, I'm going to do this a little quick here. We're going to get x is less than or equal to negative 4. So those are the values of x that satisfy this absolute value inequality. Let's look at an example where it is an AND statement. In the previous example, we saw an absolute value that had a greater than or equal to sign. Now let's see what happens if we have a less than or equal to, or even if it was just a less than. Remember, with absolute value equations, we had to first isolate the absolute value. And we drew a little house, and we said we had to get the people outside of the house, get away before we tore down the walls. Same thing here. We have to get this by itself. So I'm going to divide both sides by 3, just so I can rewrite this as the absolute value of x plus 1 is less than or equal to 3. So we have to solve for the absolute value bars first. And now let's think about this in terms of distance from 0. I'm going to mark 0 on the number line, and this is saying that x plus 1 is going to be less than or equal to 3 spaces from 0. So in the last example, we had more than 7 spaces. So let's mark 3 spaces away. Here's 3, here's negative 3. Both of those have a distance of 3. They can be, and we know that we can be at 3, so we're going to include those. The problem is, we don't want to be more than 3 spaces from 0. We want to be less than 3. So that tells us that everything right here in the middle is okay. Everything in the middle is okay. This is almost like telling your children they can't leave the house, or if you're at the park, they have to stay within 10 feet of you. So they're not allowed to leave a certain area. They have to be within 3 meters or whatever it is from a certain location. And this is what we associate with an AND statement. When you shade in the middle, typically what you'll see in this class is something shaded in the middle like this will be an AND statement. But we can just really show that writing the 2 different inequalities that we're going to get. So remember, the first one is, well, x plus 1. We see that x plus 1 has to be less than or equal to 3. The numbers that are shaded here, x plus 1 has to be at least, has to be less than or equal to 3. And this is where the word and comes in, not only are these numbers less than or equal to 3, they're also greater than negative 3. So x plus 1 has to be greater than or equal to negative 3. So these are the numbers that are less than 3 and greater than negative 3, greater than or equal to. And it follows with what I mentioned in the last example, that you will just take whatever you see, so rewrite your inequality without the absolute value bars. And then the second one is, well, you flip the inequality sign and you make the number the opposite number. Now I'm going to also remember, or give you a way to remember, which word is it going to be. Is it going to be and or? But I'll show that in the next slide. So real quick, let's just solve these. Subtract 1. These shouldn't be as hard. X is less than or equal to 2. And x is greater than or equal to negative 4. So those are the values that would satisfy our original inequality here. Now let's go to the next page. I'll show you a way how you can remember whether or not you're going to get an AND statement or an OR statement. So to remember which is an AND and which is an OR, just think of it this way. For this example where we had distance less than a certain amount, so you have absolute value and you solved for the absolute value, it's less than or equal to, or it's less than, doesn't matter, so maybe I'll include that in there. It could be less than or equal to, and this over here could be greater than or equal to or greater than. But the thing to remember is the distance has to be within. This is an AND statement, and the reason you can know that, or the way you can memorize that, is less than. So we're kind of combining the word and inside of less than. Less than, less than. That's how you know it's an and statement. And you can think of this as almost being like you can't leave a certain distance away. You have to stay within your house. Now for the greater than, this is an or statement, and the way you can remember this is distance more than a certain amount, great or. So great or less than, hopefully those are little ways that will help you remember which inequalities, which absolute value inequalities, will break down into a compound inequality.